Good morning, everybody. Hope you're having a good morning. Here's a bit of good news. There's just 3 more lessons, and that's it for our new material for the year, and then we'll be working on getting ready for your final. So that'll be a whole different thing. But congratulations, we're almost there, but that does not mean that it's light work. This is really what we've been building up to all year. So make sure that you pay attention well today and over the next 2 days, and or the next 2 lessons, and also get ready for a great Memorial Day weekend as well. So let's go ahead and hit this topic of rational expressions. Today we're going to be simplifying them, we're going to be multiplying them, and we're going to be dividing them. So really what this is all about, rational expressions. Rational, as you know, has the word ratio in it, which means that it has to do with fractions. But these are fractions that include polynomials. That's why it's a rational expression rather than a rational number. And it's in simplest form when the numerator and the denominator have no common divisors. So we need to be able to handle that. So for example, here is a polynomial divided by another polynomial. So we can't just go through and cancel out these because these are not factors. Okay, these are just terms in a polynomial. The things that are separated by addition or by subtraction are not able to be canceled out, but common factors can be divided in numerator and denominator and simplify a fraction. So we have some steps here. We need to factor it, the numerator, factor the denominator, make sure that we cancel out any common factors, and then afterwards we have to make sure that we have no situation where you have a 0 in the denominator. Okay, I'm not doing a ton of examples today. I'm counting on you guys to go back and practice because this helps you practice your very, very important factoring skills, and it also helps you practice these simplifying of rational expressions as well. So if we remember to factoring, you're looking for factors of 10. When you add them up, you get 7. So hopefully you thought of 5 and 2. Okay. Remember, you can always start with 1 and 10. Nope, that doesn't work. 2 and 5. Oh, that works. And then move on with it. Here we're looking for factors of -10, that when you add them, you get 3. So if you start with 1 and -10, nope. 2 and -5, yes, that works. So you have that. So we factored. After it is factored, okay, you've got nothing but things multiplied together here in the numerator. That's when you need to be able to cancel out anything that matches. Okay? Just like when you were factoring regular plain old fractions, when you were looking for things to divide the numerator and the denominator by, really that's where canceling comes from. So x plus 2 and x plus 2 match completely. They can be canceled. X plus 5 and x minus 5 do not match completely, so they can't be canceled. We cancel these out. So what we're left with is x plus 5 over x minus 5. That's your answer in simplest form. But we're not done until we make sure that there's been no zeros in the denominator. Now, you have to have those restrictions so that it's not just a restriction for the final answer, but in any step, if there was something that would make 0 in the denominator, that is also a restriction. So for example, x plus 2, x can't be -2 because that would put a 0 in the original rational expression in the denominator. X minus 5 can't be 0 because that would put a 0 in the denominator. So the restrictions are x can't be -2 and x can't be 5. So those two things would be your restrictions, canceling those things out. Okay. Now, I did touch on this a little bit in the last chapter when I was talking about where a graph would make a hole, and I never actually had you graphing them in the homework or anything, but this is where this kind of a thing would come in. So factor, cancel, make sure there's no 0 in the denominator. These are already factored. There's nothing to factor in these. We do have factors, like here we have 2 and 4 and all those things that are factors, but you don't have to actually factor it out. You don't have any polynomials. So what you can do is you can do the rules that we've had all the time for factors, because you're canceling out the factors in the numerator and the denominator. So for example, 24 and 6 have common factors, so they will cancel, so that you divide numerator and denominator by 6 and get 4, actually a negative 4. The negative can be in the numerator or the denominator or out in front in the whole fraction. That doesn't matter. But 24 divided by negative 6 is negative 4. There are 3 x's up here and 2 down here, so 2 will cancel and you have an x in the numerator. There are 3 down here and 2 up here, so 3 minus 2 gives you 1 in the denominator. That's way back review. But our restrictions here, the things that it is not allowed to be, x can't be 0 and y can't be 0. Those are the only things that would give you a problem, a 0 in the denominator. So this part is your answer. These are just the things that x and y are not allowed to be. So please don't think that this is your answer. This is your answer right here, negative 4x over y. Okay? All right, let's look at this. Now this one has a little bit something different. Remember way back I said that in order to factor you have to have it in descending order, so we can't forget that. So reorder if needed. We're still just doing the 3 things where you factor, cancel, and find the restrictions, but sometimes you need to reorder first. Like for example, if your x squared term or your highest term is not first, you have to make it first. And don't forget to bring the sign with it. So this negative is attached to the x. So negative x squared minus 2x plus 8. There's no sign out front here, so that's a plus 8. The other is already in descending order, so you're good. Now, if there's a negative out front, make sure that when you factor out your greatest common factor, because you're always supposed to look for a greatest common factor first, make sure you factor out a negative if there's a negative out there. So for example, this one, we're going to start off by factoring out a negative 1. And that just makes this factorable by your rules. So you're looking for factors of 8 that when you add them together you get, factors of negative 8, when you add them together you get 2. So those factors would be, think about it for a second, 4 and negative 2. And over here you're looking for factors of 6 that when you add them together you get negative 5. That will be negative 2 and negative 3. So when we factor them out, I already kind of jumped the gun and canceled a little bit here, but you would have this numerator without the slash. It's going to let me, yeah, it won't let me move the slash. That's good. There we go. So here's your factored form. And so x plus 4, x minus 2 times the negative 1, don't lose your negative 1, and then you look for the things that will cancel out, like your x minus 2 matches with the x minus 2, so we can cancel those things out. Our values here now, we have this, that this just doesn't quite look right, so once you're sure that everything is canceled out, you can multiply back in to make it look more elegant for your final simplified form, negative x minus 4 over x minus 3. Then check for restrictions. We're looking for anything that would give you a 0 in the denominator will be your restriction. So your best thing to do is to look at your factored form. So x minus 3 can't be 0 and x minus 2 can't be 0. That means that x can't be 3 and x can't be 2. And those are your restrictions. Okay? Very good. So you can kind of see the pattern. It's factor, cancel, and check for restrictions. Factor, cancel, check for restrictions. Sometimes reorder. Same thing here. We need to reorder this. So we're going to put our -4 first. Look for your greatest common factor. Your greatest common factor is 4, but since it's a negative, it's going to be -4. We haven't seen this factoring for a while, so I've got this here. Remember, you have a difference of 2 squares. So this one, the perfect square, is the square of 3. So this denominator will be x plus 3, x minus 3. Okay, here we go. Here's your factored form. Let me pull these out of the way. There's your factored form. Okay, -4 times x minus 3. You're looking for the biggest number that goes into both of them. If there's a negative out front, make it a -1. Then x minus 2, x minus 3, and x plus 3. Then you look for the ones that match exactly. -3 and +3 are not the same thing. However, the -3 and the -3 are the same thing, so they can be canceled like that. Okay, now what we're left with is the -4 in the numerator and the x plus 3 in the denominator. Okay, if you are typing in an answer, for example, if you're giving this as an answer on the answer sheet because you're typing it in, what we need to do, and it's giving me a hard time here. Hold on a second, I will fix that and then rewrite back to you. So if you were going to type this answer, you would put in -4, if it's going to let me do it, -4, and then divided by would be like this, and then parentheses x plus 3. The reason that you have the parentheses here is to show the grouping symbol when you have to type it out and you don't have access to a math type, which we really don't. You have to make sure that you show the group here. So just be careful like that if you're going to give a final answer, that you remember to do something like that. And then we can go back to considering our restrictions. Okay, in our restrictions, we would have to look at what makes 0 in the denominator anywhere. So x can't be 3 and x can't be -3. So that's where we have those things. So let's let that sink in for a little bit and move on to another. Okay, just more and more factoring. This is really just a practice in factoring. So if you would pause here, if we were in class, I'd say, okay, pause, and I'd have you guys practice factoring. So you can go ahead and do that when you factor now. We end up with these as our factors in the numerator here, and these as our factorates in the numerator and in the denominator. This x minus 5 is a group, so it can be canceled out. This is really x minus 5 times 1, so you can actually cancel it out if need be. So we're looking for things that cancel either up and down, or it can cancel across this way as well. So for example, this x minus 5 can cancel with this x minus 5. This x plus 3 can cancel with this x plus 3. And then there's nothing else that's going to cancel. So here's what happens when we cancel. Okay, x minus 5 cancels with x minus 5. X plus 3 cancels with x plus 3. Then you're left with x minus 2 and x plus 5. You could still cancel just right up and down this way if there was something that could cancel, but when you're multiplying, you can cancel across anywhere on the fraction bars. So we have this. This is not the most elegant solution. So if you were wanting to actually write it the way that it should be written, you have to actually multiply this out. X squared plus 5x minus 2x minus 10, and then simplify it to look like this. Now once again, if you're writing this and you're typing out an answer for an answer sheet, okay, let's go over this. You would make sure that you are making groups. So you would put parentheses x squared, trying to do it exactly the way that you would be able to encounter this, plus 3x minus 10 divided by x plus 1. And that will be a correct way for typing it in for entry if you're typing in an answer for entry. It's not too terribly bad, not too hard, but just so that you realize that this is the way that you correctly show, because the long fraction bar is a grouping symbol, and the only way that you have to show that is by encasing it in parentheses. Our restrictions, anything that gives a 0 in a denominator. So we'll check at this denominator. 5 is bad, -3 is bad, and -1 is bad. So we can't have them. So there can be more than just one or two restrictions. You can have a whole pile of them if you had a whole pile of denominators like that. Okay. All right, once again, here's another example. Look for your common factors. So you could have something like that for factoring. Once again, if we were in class, I'd say, okay, go ahead and work on the factoring, so you can do that for practice. Okay, then we have this, but you're going to have plenty for practice in the homework, so just factors of this last number that when you add together, it gives you the middle number. Look for things that cancel out. So for example, the x minus 4s can cancel out. The x plus 4s can cancel out. The ones that are at the same level can't cancel out. So here's some canceling. Okay, now here I showed these two x plus 4s canceling out. It doesn't matter if you choose these two or if you choose these two. Okay, the end result is that one of the x plus 4s canceled out in the denominator, and one of them x minus 4s canceled out, and we're left in the numerator with the 2 and the x plus 1 and 2 of the x plus 4s in the denominator. Then multiply it back out to make it look the best it can. 2x plus 2 over x squared plus 8x plus 16. There's our final simplified form, because we already canceled out everything that could possibly be canceled out. And our restrictions, the numbers that it can't be, well, it can't be -4 and it can't be 4. These are just other -4s, and you say it just once. So your restrictions are it can't be -4 and it can't be 4. All of the other numbers would be able to produce an answer. Okay, we have this, and then I have to show you division. So once again, this is already pretty much in factored form. Okay, they're not polynomial, well, they're monomials up here. But don't forget what to do with a negative. We'll start off just by canceling out the 3 and the 6. Okay, everything else is left alone. I want to rewrite this one so that I have no negative exponents. Remember, it can jump over the fraction bar and get rid of the negative exponent. And then once we have that, there's 2 x's in the numerator and 5 in the denominator. That means that 2 will cancel out. So 5 minus 2 gives me 3 in the denominator. For the y's, there are 3 here and 4 more here, all in the numerator. That gives you 7 in the numerator. And the denominator has 3 x's. We still have a 1 times 5 here and a 2 times 4 here. Okay, let's move on to division. Oops, the other one. Here it is. Okay, dividing the rational expressions. Dividing just has one more rule. Believe it or not, I just have one example here. It's just I want to make sure we cover it carefully and don't miss anything. First thing that we need to keep in mind is that whenever you have a division sign, remember for regular fractions, when you want to divide fractions, it means multiply times the reciprocal. So all we have to do is change this to a times and flip this one over. Change it to a multiply and flip this over. After that, we're going to reorder if necessary. Okay, and I say reorder if necessary because we're going to take this one, we have to make it in descending order. So the negative x has to come first. So just a little bit of reordering, check for that. Do your factoring. Don't forget if there's a negative, that means it's -1 times x minus 2. Factor this to x plus 1 times x plus 1. This one to x plus 1 times x minus 1. This one to x plus 5 times x minus 2. Then look for things that are going to cancel out. Okay, so we factored it. It just took a little bit of space. It's not, these factorings, honestly, I hadn't even looked ahead. I did them in my head real quickly because they factored easily. The longest thing that it takes is writing it down. So then look for things that cancel. X plus 1s will cancel. The x minus 2s will cancel. So it will look like that. The x plus 1s will cancel and the x minus 2s will cancel. That leaves us with -1 times x minus 1. And it leaves us with these to multiply together, x squared plus 5x plus 1x plus 5. We simplify, put the like terms together. That one's beautiful. So the last thing that we need to consider is the restrictions. And the restrictions are a little bit more intense this time because if there is a number that gives you a 0 in any denominator, whether it's this denominator or whether it's this denominator, those are all things that are going to be restrictions. So for example, if I'm considering this denominator, I'm saying that x can't be -1. If I'm considering this denominator, I'm saying it can't be -1, but it also can't be +1. If I look at this denominator, I'm saying it can't be -5 and it can't be 2. So here's a whole bunch of stuff, but we have to consider each denominator. Okay, this one factors to here, so it can't be -1. There's that one. This one factors to here. This one factors to here, so it can't be 1 either. This one factors to this, so -5 is a no, and 2 is a no. So anything that makes a denominator 0 in any step will mess you up. So we have that. There's your restrictions. Here is the actual answer to the question. So don't lose the answer in all that. And if you needed to type it out, okay, let's see here. We wanted to type out that answer. Just borrow from here. You would type it out as -x plus 1 divided by x squared plus 6x plus 5. Making sure that you're taking those parentheses and putting them around the numerator and the denominator to make sure that you're showing that you have the correct grouping for the grouping symbols. Okay, that's it for today. And at this point, I'll say God bless you and have a great day.